To start, I simply create a Solaris context in which I will configure Karma XPU for my renders. I'll also limit the resolution of the volumetrics in the viewport right away to avoid lags. I will create a SOP context in advance where I will do the simulation, a material library with materials for my explosions, an HDRI map, and render settings. I'm doing the basic material now, so I can go back to it and customize it in the future. Let's start by creating the solver and the basic emitter. In order to get the explosion, I will limit the appearance of the emitter to 12 frames. Most likely 24 FPS will be enough for me, thus I will save disk space when caching. Increase the limit on the number of voxels. I turn off the velocity field to save on output data, and I limit the precision since it won't affect the look, but it will save disk space. Here I play with the emitter settings to make it more non-uniform. Immediately, I add starting values of temperature and pressure to get a more explosive character. This is also transferred to the combustion, causing us to get a quick expansion of the smoke. Now it's important for me to control how fast the fuel burns and the emission stops so the explosion looks more organic. I'm adding a pyro bake volume node to visualize the temperature and density, but I won't be using it to create material later on. Pay attention to the dissipation and cooling rate parameters. The former will help me dissolve the smoke faster, and the latter will speed up the cooling of the temperature field. Division size can also affect the dissipation rate, so I'll bump it up a bit right away. I always keep in mind that my flipbook will take between 64 and 100 frames. So I should cool down the temperature in about 35 frames to achieve the impulse effect. I also keep in mind that the smoke should dissipate organically by the end of the flipbook, and that the flipbook won't start immediately. It needs time to go from a fully spherical shape to a more turbulent one. Right now, I'm just playing around with the parameters to get some detail. This explosion I'm doing without references or specific purpose. I just want to show how it usually happens in my work. Periodically, I check what timings the temperature field has. In the Ignition tab, I'll add values for temperature to indicate how much fuel will eventually be burned. This will help speed up the emission termination. I cache the result and see what I get in the frames I find interesting. I notice that frame 24 is too late a start for the flipbook. I feel like there's not enough impulse at the beginning, as if the flipbook would start in the middle. I made a few changes to the turbulence and chose frame 12 as the starting point. Caching the result and looking at the flipbook. I'm still not very happy with the shape, but we'll continue with this for now. I'll create a camera and set its ratio to 1:1. Now I'll try to find a more or less interesting camera angle. Usually I try to fill the frame space completely with simulation so that there is no empty space left on the flipbook, and the picture quality is as good as possible. Experimentally, I found out that despite the empty spaces on the first frames of the flipbook, it is not always good to zoom in and out of the camera as the simulation progresses because it causes some visual dissonance. In general, I try to adjust the zoom by the widest frame of the simulation, and then linearly animate the camera to always keep the simulation centered. It is important to keep the animation linear. Of course, I'll do a Houdini Flipbook to see if everything is good. And let's get to the render settings. It's important to add the emission and volume passes so that we can then separate them into different channels. I'll also add these passes to the denoiser. Let's adjust the light so that the smoke doesn't look flat. And also adjust the material so we can see the temperature better. I'll add samples to improve the render quality, but keep in mind that I don't want to render this for too long. Rendering 64 frames took 6 minutes on the RTX 4090. I'll set up an empty project in Nuke. First, I'll change color space to OCIO because Houdini is set up for ACES. I will also change the default viewport resolution. Using the shuffle node, I will unpack my XR to different flows. In the first branch, I'll put only smoke. In the second branch, only emission. And in the third branch, only opacity. We'll turn down the gamma a little bit for opacity so that the engine doesn't have a black stroke around the edge of the flipbook. I prefer to work with smoke whose colors are close to 1, because in the engine it is easier to make it darker than to lighten it without loss of quality. I'd like to limit the emissivity around the edges a bit. For that, I'll multiply it by a radial gradient. I also like to bake the glow into the emission. Let's make the emission black and white so we can then place it in one of the texture channels. Merge all the flows into the red, green, and blue channels of the texture without adding an alpha channel beforehand. The alpha channel lead as much as the R, G, and B channels combined. This is why I always try to avoid having an alpha channel. Contact Sheet node can help you create a flipbook. Important note: always specify the resolution of the flipbook, which is obtained by multiplying the resolution of one frame by the number of rows or columns and then reformat to 4K or 2K if necessary. In my case, multiplying 512 pixels by 8 columns perfectly gives me 4K, so I didn't do a reformat. I save the flipbook in Targa as most studios do. I also make it raw because the channels are black and white technical information, and I don't need to manipulate the colors. I would like to point out that the texture is an effect texture, that it is not compressed as much, namely in BC7, and also that it does not exceed 2K. I'll create a simple material where I'll allocate channels to the right pins. I also like to specify the usage of the material and the interaction with the depth of field in advance. Let's do emission via blackbody this time. In the particle system, let's just randomize some parameters to check how our texture works. Sometimes I like to optimize the system a little bit right away. I'll add a dither if we want to make the material masked. I'll add the ability to customize the material from the system. Maybe the glow is too obvious, it looks too bold and undetailed? I'll try to fix that by changing the approach to creating the glow. Still looks like a stylized spot, means this needs to be given more time in Houdini among other things. Instead of changing that now, let me quickly show you how to avoid overdraw by cutting off the extra space on the sprite. That's roughly how I've structured my workflow. Thanks for watching.